So good afternoon. Maybe welcome back if you were there in the first session that we held this afternoon at 2 in the same room. My name is Sebastien Stormacq. I'm a solution architect working for Amazon in the Alexa team. I'm helping customers to develop Alexa skills.
Good afternoon again. My name is Danilo. I'm part of the technical evangelist team in AWS. And this second session is completely unplanned because we were asked to cover for a speaker that was not here. So we are taking this opportunity to dive deeper into the technology that we use in the demo today. So on the Alexa skills, so the voice recognition platform on one side, and on machine learning on the other.
So just a quick poll. Who did attend the first session at 2 p.m. this afternoon? Half of the room, okay?
Yeah.
If you didn't attend, don't leave now. We'll try to catch up really quickly on what we said. Not too long to not bore the other ones, but just to give you enough overview of what we're talking about.
So what we covered in the previous session, there was a very long and boring introduction that I delivered on machine learning just after lunch. The idea was to have clear the terminology, the use cases, and how you can use machine learning to learn from data. Then we moved into creating a model. It was a bike sharing model to understand how many bikes were used in a bike sharing in a town. We used a public data set from the town of Washington in the US. And then we built an app using a Lambda function that was used by Alexa with a voice interaction with capabilities.
And what we are going to show you now is really a step-by-step instruction, how to create a Lambda function, how to create an Alexa skill, and that will be the first part. The second part, Danilo will come back to the machine learning and the data model using a different data set, a banking data set.
Yeah, I will use a different data set. Instead of regression, I will show binary classification, that is very common use case.
Okay, that's the menu for the next hour. Thank you for being here. We are the last obstacle between you and the drink tonight and the end of the day. So this is the demo that we use, the architecture we used for the demo during the previous talk. I was talking to Alexa. Alexa did the speech recognition in the cloud and sent an intent, which is really the meaning of what you said, to some code that happens to be hosted on AWS in a Lambda function, and I will talk back about Lambda. That Lambda function was querying a weather forecast API and was calling the machine learning prediction model built by Danilo to get a prediction about how many bikes would be available or used in a specific station in Washington, D.C. That was a setup, and during the next 20-30 minutes, we are going to talk about the left side of this graph, how to build a skill, how to create a Lambda function. I will not write code in front of you, I will use a template, but we are going to go through all the steps in the console. So, how do you create your first Alexa skill? For those of you that were not there before, just how it works is that the flow is the following. I'm talking to Alexa, and Alexa is just a bunch of microphone, a speaker, and a network interface. That's an echo device, and the echo device talks to Alexa who lives in the cloud. Alexa is the Alexa voice service. It's a free and open API from Amazon that everybody can use as long as you have a device with some compute capabilities, a microphone, a speaker, and a network interface. You can interact with Alexa. So these devices are built by Amazon and are interacting with Alexa. Alexa will do the hard things, which is the speech recognition and the natural language understanding. Speech recognition is going from what I say to a couple of text words, and the natural language understanding is the second part of the process. It's to transform my words into some intent. What did I mean? Now, if I say, Alexa, play music, it has to recognize that play is the verb, music is what I want to play. Maybe I can say, play Michael Jackson. It has to recognize that Michael Jackson is an artist. So it's giving a meaning to your words. So we are doing that on the cloud, and we are, of course, running on AWS to do that. And if we detect that the intent is for your skill, we will send a JSON document, a JSON request to your code. Your code might be hosted anywhere on this planet, any endpoint that can talk HTTPS, receive a JSON document, and give back a JSON document is valid to implement an Alexa skill. Of course, we are Amazon, so we love when you deploy your code on AWS, but once again, it's not mandatory. You can run on-premises, you can run in Google, Microsoft, IBM, any other cloud provider that are out there. Your skill code then must do something. If you are ordering a pizza, your skill code will probably call the Domino Pizza API. If you are building a skill to call Uber, a Uber car, your skill will call the Uber API to order a car. What you do in your skill is really dependent on the user interaction and the functionalities you want to provide to your customer. But at the end, you must return us a JSON document. So the output of your skill is a JSON document. We will process that JSON document in the cloud, and we will generate the voice of Alexa in a text-to-speech, or you give us text, and we generate the voice of Alexa in the cloud, and we stream the voice back to the device. Wow, that's a long explanation. All that happens in a few milliseconds, the time to stream to the cloud, call your code, and go back with text. So when you create a skill, there are two parts in the skill. The first part is the code, and we are going to use a Lambda function written in Node.js to do this demo. The second part is the voice model. The voice model, it's made of three different things: intents, utterance, and slot. The voice model is what will help Alexa to understand the dialogue and the type of phrase you expect your customer to pronounce. So you have to create a design for the voice interface, for the voice interaction. And this design is made of three different parts: intents, utterances, and slots. The intents are the function inside your skill. You are a developer, so you know what a function is. If you are building a skill to order a pizza, you will probably have a function order something, a function about status, a function about payments. These are the intent. You define intent by just providing a JSON document in the Alexa developer console, like this one, but I will create something more complex in front of you in a minute. To support these intents, you need to give some hints to the Alexa speech recognition system so that we can better understand what your customer will pronounce. So you need to give us sample utterances. It's all the phrase you expect your customer to pronounce to interact with your skill. And we will map this phrase to a specific intent. So it's very common for intents to have hundreds of sample utterances, all the possible variation, correct or not correct at grammatical level, that you expect your customer to pronounce to interact with Alexa. Whenever we will hear say hi, or say hello, or say good morning, we know that we need to map that to your hello intent. And what we are going to send to your function, it's the hello intent. And of course, all functions in programming, in Alexa, in all part of life, all functions have parameters. And these parameters, we call that a slot. If you order a pizza, you might expect to have a parameter, which is the type of the pizza. If you are predicting the number of bags that would be available, at a bike station, maybe you expect a date and a time as a parameter to your intent. So you can create your own parameter, your own slot, which is a list of value you expect your customer to pronounce and to give to Alexa. Or you can use one of the predefined slots that we have, like a date, a duration, a PIN code, a first name, a country name, city names, and we have a growing list of built-in slots. That's enough for the theory. Now let's do some hands-on and try to create a favorite color skill. So the skill will work like, Alexa, open my favorite color skill. And Alexa will answer me, hey, what is your favorite color? I will say red. And she will say, oh, your favorite color is no red. I will remember that. You can ask me, what is your favorite color? So I will say, what is my favorite color? And she will answer me red. So it will show you the basic construction of a skill using the intent, the sample utterances, and the slots. It will also show you some concept about session management, because it will remember a value between two different questions. I will say, my favorite color is red, and then in the second phrase, I will say, what is my favorite color? And she will answer me red. So she will keep the state of my dialogue. She will keep some value from my dialogue. I was about to say in memory, but it's not really in memory. I will give more details. Okay, let's go. The first part is to create a Lambda function, to create a piece of code that will receive some JSON document when you talk to Alexa, and that will give back some other JSON document as a result of your code execution. And I will use Lambda to do that. For those of you that are not familiar with Lambda, Lambda, it's a code as a service. We can define that like that. It's a container for your code. As a developer, you write code, you upload the code to Lambda, and that's it. We do take care of running that code for you in the cloud. So we do take care of the underlying infrastructure. Of course, there are virtual machines, but it's totally hidden from you. Of course, there is an operating system, but that's totally hidden from you. We will run the code for you. We will take care of the high availability of the code. Your Lambda function will always be available. And we will take care of the scalability of that code. So if you are calling, if you have a lot of calls in parallel in the Alexa world, for example, if you have many customers interacting with your skill, you will receive a lot of calls in parallel. We will scale your Lambda function automatically for you. So you, as a developer, you don't have to take care about these low-level infrastructure details, such as high availability or scalability. So let's create our first Lambda function. I am in the AWS console, which has a lot of different services. By the way, this is a new console. If you didn't see it yet, just click on Lambda, and you have a list of functions that are already created. Let's create a new one. One very easy way to discover Lambda is to use one of the blueprints we do provide. A blueprint, it's just a template. It's a predefined Lambda function. And actually for demo, this is really good. This is what I'm going to use today because I don't want to write Node.js scripts in front of you. So let's search for a Lambda function called Alexa Skill Kit Color Expert. And you can see from that we have two different templates. One is in Node.js, and the other one is in Python 2.7. So let's take the Node.js one. The second step is to actually define what are the services that will be authorized to call your Lambda functions. We don't want anyone on this planet, anyone connected to the internet, to be able to call your code. You want only the Alexa service running in the cloud to run your code. So when you create a Lambda function, you have to tell us, you have to tell AWS what will be authorized to call your code. And we call that the triggers. So you have to configure the trigger. And in the list of trigger, we have Alexa Skill Kit. So if you want to create a skill, you define Alexa as one of the valid trigger for your function. The next step is to give a name to your function, Alexa color demo, and you see that the code is already populated for you. So if you have a very simple code, you can edit your code directly inside the AWS Web Console. Of course, in real life, you will probably not do that. You will use an IDE, and we have an API that allows you to upload a zip file with all the dependencies that you need for your function instead of just editing the code there. Want to add something about Lambda before I'm diving into the code?
No, I think we can show afterwards the different parameters to create a Lambda function.
Let's go down to the code level there, in the order of the screen. This is a very simple skill. So we are taking care of all the basic low-level stuff, such as parsing the incoming document, generating the output answer. The core of the skill is here at the bottom. Export handler, this is the entry point of that code. And basically, we are going to inspect the JSON document that we receive. And based on the type of request that we receive, we will call one function or another function within the code. In real life, you will probably not write something like that because we have SDK, we have a Node.js SDK, which hide that for you, which provide a higher level programming interface. All these routing and JSON analysis and routing to correct function is a part of the Node.js JSON SDK. But it's very good to learn because when you're going through that code, you have to go through the details and understand exactly what's happening behind the scene. So depending on the request you receive, it might be a launch request. A launch request, it's when you say, Alexa, open and the name of your skill. That's a launch request, and we will run that to an on-launch method. You can also receive an intent request. An intent request is when I'm answering a question to Alexa. So I say, Alexa, open a color demo. She will say, hey, give me the name of your favorite color. And I will say, my favorite color is red. That's an intent request. My favorite color is red, red being an attribute, a slot. So I will route that to OnIntent JavaScript method. And the same for session-ended request. So if we look at the OnIntent function, it's basically a dispatch. It's a big if-then-else statement. We look at the intent name. You might have multiple intents for your code, multiple function, and we'll just dispatch that to the correct function. So if the intent name is my color is intent, we go to set color in session function. If the intent name is what's my color intent, we go to that function. And that's these are the basic stuff that we take care for you in the Node.js SDK, but it's good to go through that once in your life to understand the logic behind the scene. From there, we prepare the answer. So we prepare the speech output. I know that your favorite color is blah, 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 blah. And we call a function called build speechlet response, which will prepare the JSON document that our function will return back to the Alexa voice services. So pretty simple code. There is what comment include. There is 25 line of code. The entry point for that function, it's the handler, it's index.handler, and I need to tell Lambda which permission to use. So warning, this is more advanced AWS. If you are lost with that, don't worry. When you execute code within Lambda, you need to give permission to your code if your code interacts with other AWS APIs. So you need to tell explicitly that you authorize your Lambda function to call other AWS API. How do you do that with AWS in general? You are using roles. A role is just a container for permissions. And I have a role already defined called Lambda basic execution. That role gives my Lambda function just enough permission to interact with the logging service from AWS, CloudWatch logs. So that function will have enough permission to write logs to CloudWatch logs, so I will be able to see what's happening within my function. And actually, we do that for you almost automatically. Whenever you use console.log in JavaScript or print or the logging framework in Python, we redirect that to CloudWatch log. So you need to give your Lambda function enough privilege at least to write to the logging service, and this is what that Lambda basic execution role is doing, and we can create that role for you if it doesn't exist yet. The last part of a Lambda function is the size of the memory that you will allocate to the runtime environment of Lambda. So when you will execute that Lambda function, when we will execute that Lambda function, how much memory do you want to allocate to the container that will run your function? And you have the choice between 128 up to 1.5 megabytes. And we have a kind of one-to-one mapping between the size of the memory and the CPU allocated to your function as well. I don't know the numbers out of my head. I have to go back to the documentation for that. But the idea is that if you allocate a small amount of memory, you have a low amount of CPU power as well. If you allocate a bigger amount of memory, you have more CPU power, so your function might execute a bit faster if it is CPU dependent. There is also an impact on pricing. During the first session this afternoon, I told you that the pricing model for Lambda, it's based on the number of invocation, 20 cents. I'm talking in US dollars and without VAT. So 20 cents per million of invocation. So every time you invoke a Lambda function a million times, we charge you for 20 cents, except the first time. So the first million is free, every month. That's part of the free tier of AWS. So you don't pay for the first million invocation per month. To be complete, it's not totally accurate. The number of invocation is not the only pricing for your Lambda function, because if your Lambda function is running for 2 minutes, or if your Lambda function runs for 200 milliseconds, it doesn't involve the same resource usage on our side. And the general rule at AWS is that anything that consumes resource on our side has a price for you. That's pretty honest and pretty fair. So if you are consuming more CPU, you will be charged a bit more. So on top of the invocation price, there is a very small, tiny price per CPU cycles that you are using within your Lambda function. And we charge you per 100 milliseconds of execution time. And the price depends on the size of the container. So a small container will be charged less than a larger container. Don't ask me about the exact price. That's exactly the type of information that I cannot remember, but we have full details on the Lambda pricing page. If you Google AWS Lambda pricing, you will find the details of the price. VPC, for those of you that knows about AWS, this is a private network that you can build inside the cloud. We are not going to go into these details. So just a quick review. The trigger of that Lambda function will be the Alexa skill kit. Alexa color demo, Node.js 4.3, the role, the memory, the timeout. Let's create that function. So creating the function is almost immediate, so I can see the code, I can see my configuration, I can see my trigger, I can change all these as well, but I can also test my function directly from that console. So if I click test here, I can prepare a JSON request that will be sent to my Lambda function. And you saw the Alexa request in the previous talk maybe. It's quite long, it's quite complex. I don't want to type here something. So either I can copy paste from something I recorded previously, or we do provide sample requests as well. So if you click on sample event template, we do provide templates for different type of events that can trigger your Lambda function. And if you scroll down to the Alexa section, you see that we have a start session, end session, smart home control, and my colors intent. That's exactly the request which will be sent when I will interact with that skill. So we have a session, we have a user ID, an application ID, and of course we have the intent and the slot. So this is a my color is intent. We'll define that in a minute, with a color slot of value blue. So this is exactly what Alexa voice service is sending to your skill when me, as a customer, I will talk to Alexa saying, hey, Alexa, open my favorite color. Alexa will ask me, what is your favorite color? And I will say, my favorite color is blue. When I say that, the speech recognition and the natural language understanding will transform that into this. What you will receive, your code, is that JSON document saying that the intent was that intent. That's what we hear. That's what we recognize. And the value is blue. The value of the slot is blue. So let's invoke that Lambda function with that JSON code. I just can click save and test and see what will happen. We see the execution result here. And the execution result is another JSON document. That's the one generated by my Lambda function. This time, it's a response with the output speech. I now know your favorite color is blue. You can ask me your favorite color by saying blah, 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 blah. So that's a very convenient way to test your Lambda function. You can do that from an API. You can do that from the command line as well. It means that you can integrate your Lambda development into a real development workflow with a continuous integration or continuous deployment as well. Everything I'm doing here in the console as an API. So everything I'm doing right now in the AWS console can be automated, either from the command line, either through a REST-based type of API. So now that we have some confidence that the function is working and returning a valid answer, by the way, you can see the log file that has been generated by the function as well. We receive an intent. This is the request ID. The execution time was 8 milliseconds. I'm sorry, we are charging per 100 milliseconds, so we will charge you for 100 milliseconds execution time for that. When I say charge, it's really 0.00000 something per 100 milliseconds of execution. I have some monitoring information as well, the number of invocation, the duration of the invocation, because these are two important metrics, not only for your customer in terms of latency and the experience they have, but also for your credit card, because these are the two metrics that we are using to bill you at the end of the month. So you can monitor the errors and you can monitor the number of invocations that have been throttled. Throttle means if you have too many concurrent invocations, we will queue them, so we will throttle them a bit. I don't remember the limit. I think it's so 100
per default is 100 concurrent executions, but it's a soft limit that you can increase. It's there more to avoid maybe a human error that you launch too many functions and you don't understand. So we're happy to increase it.
The limits that we are putting on our service is not to bother you, it's just to protect you from shooting you in the feet, because it's quite easy to write a buggy script. It's actually much easier to write a buggy script than a correct one that will invoke your Lambda function, and you don't want to have a bad surprise at the end of the month because you have written some incorrect code. Okay, that's the part for my Lambda function. My Lambda function receives a JSON document, send back a response ready to consume by the Alexa voice service. So now let's create the skill. And to create the skills, I'm sorry, I need to switch to another console. And this is not the AWS console anymore. This is the Amazon developer console. So the address of that console is developer.amazon.com. The good news is that if you have a retail account, if you are shopping on Amazon, you already have an account to use that as well. You can just reuse your email and the password to access that console. You click on Alexa and Alexa Skill Kit. The difference, voice service is if you are building hardware and you want to integrate the Alexa experience inside your hardware. The Skill Kit if you want to bring another capabilities, another application to the Alexa platform. So let's create a skill. You see that I have already 2 skills, and I will click here, add a new skill. Different type of skills. Will not enter into the details given the time we have, but we are creating a custom interaction model. You can choose your language. As I said earlier this afternoon, we do support US, British English, and German. I will use British English because this is what my echo is configured for, my dot. Let's give a name, color, demo, Devox, and let's give the invocation name. The invocation name is really important because this is what your customer will need to pronounce to start your application, to start your skill. When you say, Alexa, open my color demo. So I will need to pronounce, Alexa, open my color demo. Or Alexa, ask my color demo what is my favorite color. So this is the name that Alexa will recognize, and based on that name, we know that the intent is for your code, and we will route the request to your code. Next, I need to give my intent schema. So what are the intents I'm going to support in my skill? My custom slots, if I have any, and the list of sample utterances. So for this demo, I will cheat a bit and copy-paste these values, because once again, I don't want to type that in front of you. So I have an intent schema ready here. By the way, it's a public URL. If you search for a color demo Alexa skill on Google, you will find that. It's a step-by-step tutorial that you can follow to redo what I'm doing here right now when you will be back home tonight or tomorrow night. My intent, oops. So let's have a look at that. I have my color is intent. This is when I say my favorite color is blue, and that intent has 1 parameter, 1 slot of type list of color. I also support what is my color intent and help intent. Notice that this one starts with Amazon. It's a pre-built intent. You have to implement that in your code, but you don't have to define any sample utterance for that. Talking about sample utterance, let's copy my sample utterance for my 2 intent. I just told you that Amazon help, you don't need to provide any sample utterance for that. So I have 2 intent. What's my color intent? And I expect the customer to say, get my color, get my favorite color, give me my color. In real life, you must generate hundreds of these, and it's quite easy to write a Python script that, based on a couple of patterns, generates these. The more you have, the better the speech recognition will be, so the more accurate the speech recognition will be. This is a very bad example. For example, the my color is intent. We have only 1 sample utterance. My favorite color is red or blue. So it means that I really need, when I will answer Alexa, to give that sentence. If I'm giving something else, Alexa will not be able to route what you say to that specific intent. So for a demo, it's good. In real life, it should be a big red flag on your development to-do list when you have only one sample utterance for an intent. Let's create my list of color custom slots. So that's the type, list of colors, the type that I have used here, list of colors. And let's give a couple of values to that. It's not a closed list of value, it's just some hints for the speech recognition system to recognize what you're expecting. But if the customer say banana, and we have a quite high confidence that we correctly hear banana, your code, your skill code might receive as a value banana, even if banana is not in that list. So it's not a closed list, it's an open list, it's just a guide for us to guide the speech recognition engine. And click Save. Notice that the save can take 1 minute or 2 minutes because we are really building a binary representation of that voice model. And we will inject that at runtime dynamically on the customer account when the customer will actually activate or enable the skill on their account. So there is some background processing there. We collect this value and we create something that will be injected in the speech recognition system at runtime. And we can see it successfully update. The time depends on the time of the day because we have a queue, and it depends on the complexity of your model as well. Obviously, the more complex is your model, the more time it needs to build. Last step before testing that skill is to tell the skill where is your code, where should I call, where should I pass, where should Alexa pass the JSON document, where is your code. And we do support either Lambda, either any HTTPS endpoint. So if you want to run inside your data center, feel free to do so. You just need a highly available, highly scalable, secure web server to maintain and to operate. So that's why we choose Lambda here. I have nothing to operate. I just deploy my code. My code, because it's a UK skill, lives in Europe. But if you are targeting US and UK, you can have 2 different versions of your code, so 2 deployments on 2 different Lambda functions. And for Europe, I need to give the reference to my Lambda function. So I'm going back to the AWS console. And this is the reference to my Lambda function. We call that an Amazon resource name. That's a unique identifier of a resource within the Amazon cloud. And next. Et voilà, my skill is ready to test. So it's already implemented. You have a test button. As soon as it is enabled, it's enabled on your Amazon account. So this echo, this dot, is connected to my Amazon account, and the developer console is connected to my Amazon account. So it's already live on the dot there. But before testing live on the dot, I will do another text-based test to ensure that the end-to-end system is working correctly. And I can say things like launch my color demo. That was my invocation phrase. So launch is one of the many verbs we recognize. It might be open, tell, ask, launch, and we have a long list documented in our documentation. If I click on that, the JSON request that will be generated, it's a launch request. So there is no intent there. So it will be routed to the get welcome JavaScript function, if you remember the JavaScript code. So this is also something you can copy-paste to test your Lambda function. Remember the test with Lambda? You can copy the request from there and use that in the Lambda console. And this is the response generated by our skill. So this is the response that has been generated by the Lambda function. You can play the response, if I do that.
Please tell me your favorite color by saying, my favorite color is red.
So you can hear what will be the sound of Alexa. If something sounds strange, you can change your text. But if this is working, this should work as well. You can say, for example, Alexa, open my favorite color. No, it's my color demo. Sorry, I screwed it up. So she will not recognize that because I have no skill with that invocation.
Sorry, I can't find the answer to the question I heard.
That's a very good debugging experience because this will happen to you in real life all the time. So, Alexa, open my color demo.
Welcome to the Alexa Skills Kit sample. Please tell me your favorite color by saying, my favorite color is red.
My favorite color is blue.
I now know your favorite color is blue. You can ask me your favorite color by saying, what's my favorite color?
What's my favorite color?
Your favorite color is blue. Goodbye.
So 30 minutes and you have your first skill working. Can I take another 2 minutes on your time just to explain something? As long as the blue light is on the top of Alexa, it means she's listening to you. And maybe you notice in my dialogue, I say open my color demo, and the blue light stay on. She talked to me, and the blue light continued to stay on, meaning that she's expecting an answer. I give the answer, and during all that dialogue, the blue light stays on. What we mean there, what we have there on the background is a session, it's a dialogue. It's from the moment the blue light goes on until the moment the blue light goes off. And that dialogue might involve, just like in a real human-to-human dialogue, multiple question, answer. And we have a concept of session and session variable, so your code can store session variable between different steps of the dialogue. And this is exactly what we did with the blue color. I say, my favorite color is blue, and she immediately answers me, okay, I know that your favorite color is blue. And I say, what is my favorite color? In terms of Lambda, if you think about that, it's two different invocations. My Lambda function here has been called 3 times. Open the skill, say my favorite color is blue, ask what is my favorite color. So it's 3 different invocations of the Lambda function. And Lambda is totally stateless, so it might even be handled by different machines in different data centers. We don't know. Lambda is totally stateless. So to keep that state and to keep the fact that Alexa remember that my favorite color is blue from one question to the other, we have that concept of an Alexa session, which is the entire duration of the dialogue when the blue light is on Alexa. How does the session work? It's something that we give you my favorite color is blue. It's something that we give you in the JSON. So there is no persistence on the Alexa backend that wouldn't scale. So what we are doing, we give you your session content in the request. It's part of the session attribute there. You see, you have this attribute. And you as a developer can use that field to give us a couple of values, like to persist the fact that my favorite color is blue. So one of your response might include a session attribute as well. And the promise we are doing to you is that for the next request in the same dialogue, you will retrieve the same value in the attribute of the session. So it's not really persistence on the server side. It's very different from HTTPS session for sure, but it's a very scalable and stateless way to maintain some state in between question and answer, as long as you are part of the same dialogue. And this very simple example of color shows you how to manage the session as well. If you have a look at the code, you can see that we are storing the session attribute inside these JSON attributes. We have something here called session attribute, create favorite color attribute, and we just return the favorite color as a JSON object. So this is how you can manage the state of the dialogue when you ask a question, receive an answer, ask another question by persisting the state in the session attribute part of the Alexa request.
I was talking with someone that wanted to build like an ordering interface, so you can build all the parameters that you need for an order in the dialogue in this way, and then when you have all the information, you can complete the order.
Another example is to handle the yes/no intent. You might ask to your customer a confirmation about something, and you expect a yes/no intent. But that yes/no intent might arrive at different stage of your dialogue. Maybe you have a very long dialogue, a yes/no at the beginning, a yes/no at the end. So from your code perspective, you just receive a yes/no intent. So you have to map that yes/no intent to the stage where you are in your dialogue. And one way to do that is to persist the stage of your dialogue inside the session, so that you know when you receive a yes intent and you are at stage 8, you know that the next step would be that. I hope I'm clear for everyone. It's probably a bit hard for the end of the day. Anyway, machine learning.
Yes,
because
just to light up the environment, so machine learning.
So you saw how to create the skill with a Lambda function and the skill. Let's see the other part of the demo that we did this morning with the machine learning and the binary models.
Thanks, Sebs. I find really voice interaction model fascinating because they're so different from what we used to program in normal web interface, and there are different problems. But maybe one parameter for recognizing the quality of an interface is the range age of people that can interact with something. So, and we see that with these voice interaction models, you can have very young people and older people interacting very easily, where it's not that easy with smartphones and web interfaces. Okay, so let's move to the second part. So today, when we built the whole bike sharing skill for Alexa, there was an interaction with a machine learning model that was predicting the number of bikes used in the Washington bike sharing service. That was a regression, so I was predicting a number, an integer variable. Actually, for the prediction engine was a floating point. I was rounding the result because the prediction could say that 3.2 bikes were rented, but I was rounding that up to avoid confusion. Now I want to do a different example. So I'm still using the Amazon machine learning platform. As I said today, this is a platform that was designed to be used by developers so that you don't need to be a machine learning expert. And that's what the same engine is, the one that we use internally to Amazon for all our teams. We can build batch predictions, so you provide a set of data to predict and we give the predictions, or that was what we use today, give real-time predictions, so in the matter of milliseconds you can ask a trained model to give a prediction depending on the data. We support regression, and we tested that just after lunch, and then classification. I will do an example of binary classification that is probably one of the most used cases. As I already said, email spamming is a case of binary regression. This email is spam or not. Another example is customer that are at risk of leaving your company. So if you want to predict if a customer maybe is going to leave your company or not in the next week, you can build a model, and this would be another example of binary classification. So let's see how you can do that. And I will do a different demo, so using binary classification with a banking product. So the scenario here is that you have maybe your own customers, you launch a new product, and maybe you start contacting your customer, maybe 1,000 customers, to see if they are interested in buying this new product. After you call your first 1,000 customer, you can start to use this data. This is an example of supervised learning, to build a model that will predict how all your other customers can be interested or not in this product, so that you can focus all your energies in calling only the customer that probably are going to be interested in this product, and you will also improve the customer satisfaction because you are not going to call people that will probably not are not interested in that. So let's go on the Amazon console. I have an account with the old console. And here we have machine learning in the analytics section of the console. And here I can create a new data source, a new model. We have this nice interaction here in the bottom of the console that gives you an idea of the necessary steps to build a model, also what's required on your side. So the first step is to upload your data, and also you need to analyze and understand your data and maybe clean your data. If you were here in the session just after lunch, when I was looking at the data for bike sharing, I was drawing the data using different parameters like the day of the week and the hours of the day, and it was easy to understand that there were patterns, so people using the bikes in the morning and in the afternoon for commuting, and people using the bikes over the weekend just for leisure. And then we understood that these were different population of users. So looking at graphically at your data is the best way to understand it and maybe change it before creating the model. The second step is to create and train the model based on the data. And this is usually not a single step. So you create a model, you evaluate the model, and based on the evaluation, you can understand how good the model is working, and then you can try to change something. So today, for example, there was a date in the input. So of course, in the data that I was using, I had the day, the historical data of bike sharing, I have a date, and then I was looking at how much bikes were rented. But the day of the week was an information that was not very easy to understand for a machine. So adding a new column saying, okay, I know that the day is November 10, but this is also a Thursday. This can provide information because bike rental on a Thursday is different than a Sunday. So you can enrich your data, you evaluate again your model, you train again your model, and you see if this change in the data is creating an improvement or not in the evaluation of your model. And then you can start building real-time or batch predictions. So I will start creating a data source, so loading the data, and a machine learning model. I already stored the file on S3, our object storage, and I have data here in a bucket. I have, you can see a few examples. This is the banking examples, and this is the banking CSV. This is a CSV file that actually we can also open here to have a brief look before loading it. So this is something that you can, it's not big, so you can even manage it with Excel. And what you have here is a file that tells you all the characteristics of your customer, so the age, the kind of job, marital status, the kind of education, how it was contacted, it was cellular, on the landline, when it was contacted, the day of the week it was contacted, the duration of the call, and at the end of all these parameters, you have this final column that is called Y, that has a 0 or a 1, and that means if the customer at the end of this contact bought or not the product. So zeros means that he was not interested, and ones are when the customer bought. So this is, for example, what you can do with your first 1,000 customers. Now I will load the same file here. Let's call it Devox banking, just to recognize it. Now the platform is checking that we can read the file, and now we can tell this is a CSV, and the first row contains the name of the columns, so I can tell this to the platform. And the platform is looking at the data and trying to understand the data type. So for example, the age is a numeric field, the job is a category because there's a finite set of values, the day of the week is the same, and so on. And the final value, the Y, is recognized as a binary value because it has only two different values. It can also be two different strings. It doesn't need to be 0 and 1 to be recognized as a binary by the platform. Now I need to tell to the platform which is the target. So of all these variables, which is the target that I want to predict, and it's exactly the final column, the Y. And this will mean that this is the variable I want to predict. All the other variables will be features that I use in the input for the prediction. So I will need to provide all the other values to predict this final feature, the Y. We don't have an identifier. This is a classical recap, and then they click continue. So this will create the data source, so importing the data. And now I can create the model. We have a default model that is what I suggest you do as a starting point. We will use our own best practice to create the best model for the data. Or you can customize, and you can change how we manage data with what we call a recipe. An example, if you have text, you can say how you want to manipulate text. For people that is into text processing, you can create n-grams or structures of that kind. But normally you don't need to do anything. And the idea is really to work in an iteration. So you build the first model, and you evaluate the result. Then you try to change something, and you see if you improve or not. So let's use the default settings. And I can create the machine learning model. So now the process has started. If I go here in the dashboard, I see that we have activities in process. So the first is the import of the data source, the 100% of the file. Then we are splitting the data source in two parts from 0. This is not very easy to see, but it's from 0 to 70%, the first part of the file. And this 70% of the data will be used for training the model, and from 70% to 100%, so 30% of the data will be used for validation. And it is a very good best practice for machine learning with supervised data. So you put 70–80% of the data on one side for the training, and then when you have a model, you test the model on the 20–30% of data that you put on the other part on a side, and see and you can build an evaluation. You can understand how well is your model abstracting the information from the training data on the validation data. Then you have the model itself and the evaluation. This usually takes roughly 10 minutes, so that's why I already created it a couple of hours ago. So here we have the machine learning model. I can click here. And we have, it took 3 minutes to be created after the creation of the data sources. 2 minutes were the actual compute time. And here we have the evaluation. And this is a binary classification, so the normal metric to evaluate a binary classification is the area under the curve. And this is a value that goes from 0 to 1. 0.5 usually means completely randomness, so it's like throwing a coin. 1 means that you are 100% perfect in the prediction. 0.93 is a very, very good result and shows that this is fake data that I prepared for this demo, because with real data you will never arrive to 0.9, 0.7, it's maybe already good. But there's an interesting information that you can get if you click on the value. You can you have other information on the performance of the metric, and you can explore the performance. So this is a visual representation of the curve that we were looking only at the area below the curve. And this is telling you, depending on the number of records, how many records are correct, so it's 91% correct, and how many are errors. And there is a very important information here, because the errors can be of two kinds, can be false positive or false negatives. So you can make a prediction that say, okay, this customer can be interested in this product, but he will not. Or the opposite, this customer is not interested, but actually this was the product that he was searching for all his life. So how can you manage this? We can only tell you what are the results, and the value of false positive and false negatives depends on your use case. For example, let's say that this is a spamming platform, so a spamming model, so it can recognize if an email is spam or not. Maybe you receive so many emails that you really want to get rid of all your spam. If sometimes you miss an email from a normal friend, you don't care because you really want to remove all your spamming. So in this case, the false positive, so if I recognize an email as spam, but it is not, sometimes can happen, it's not a big problem. On the opposite, maybe this is the email for your company where you receive the orders from your customers. So you want to get rid of spam, but you don't want to miss an order because that's how you survive as a company. So in this case, you really don't want false positive because that means that you can lose an order from a customer. Other interesting use cases where you can understand the difference between false positive and false negatives is if you apply this to healthcare. So imagine you have a large population of people and you don't have the resources to do some medical test on all the people. You may want to select a subset of people that is at risk and then test all these people. In this case, a false positive is not bad, because if you have someone that is not affected by this illness, but you test it again, it's not a problem. But you don't want to have false negative, because if you say, okay, this person is not to be tested because he's not at risk, but he was at risk, then you miss the opportunity to correctly run the test and classify the person. So it really depends on use case. And here you can change the model, moving the threshold that we have on the graphics, and this is changing the number of false and positive and false negative between the two range. So you can use this to customize the threshold depending on your use case to lower or increase the false positive or the false negative. Usually 0.5 it's a good starting value, and then you can fine tune. Here there are other classical metrics of machine learning, such as precision, recall, accuracy. They have basically the same meaning as this information, but they used as a standard language among data scientists. You can change these values, and this is affecting the same threshold as before. So now that we have the model, we can use the model. So how you can use it? You can run a batch prediction, for example, and that means that you take a large file, such as this one that I have here. So I'm opening this file. This is exactly the same file as before, with all the information of my customers, but there is no final Y column, because these are other customers. I don't know if they will be interested or not. So I can do a batch prediction by giving all this list of customers as a CSV. The platform will evaluate all of them and return the prediction for all of them at once. This is one way to interact with the platform. And the other way is to generate real-time predictions. You need to enable this. If you generate real-time prediction, you get an endpoint URL. And then you can call this endpoint URL with our APIs to ask for a prediction with a single data point to predict. You need the endpoint and the ID of the machine learning model, this information here on the top. And just as an example, this is how you can use this from our SDK. So this is the Java SDK for AWS. We have an Amazon machine learning interface. And here we have the predict method that you can use. You create a predict request where you include all the information, so the ID of the model, the endpoint, and all the variables that are required by the model, and you get a predict result that will tell you which is the result. The same is available in JavaScript, for example, in Python if you want, and in a lot of other languages. You can also test the real-time prediction straight from the console. So this is all the field that you need all the fields that you need to fill to run a request, because all the fields are required. Just to find some example, I can run an head command on the file that we saw before. I can copy one of the lines. So this is one customer from the that I want to predict. So I have the age, he works in services, he's married, he did a high school, and so on. I copy this as a CSV. I go back on the interface. I can paste a record. This will automatically populate the interface. Then I can create the prediction. And this is what I get for this prediction. So in this case, I get the algorithm that was used. The kind of prediction is a binary prediction. The predicted label is 0, so this customer is not interested. And if I look at the score, it's a very, very low score. It's 0.03, so it's very low. So it's really not interested in this product, and it would be really a waste of time to call him and contact him. So in this way, you can use predictions in your application, and it was exactly what we did this morning. So the only difference was that it was a regression and not a binary classification. Going back to the slide, I think we are really at the end of this session. I hope it was interesting, because we had the opportunity to dive deeper into the products and the technologies that we were using today, and we are more than happy to take some questions. Please? Yep. Mm-hmm.
The second question, can I have, for example, the link between slot type and category and product? And the third question is, how can I enrich my iterants? Because I will begin, for example, by 20 iterants, and of course I have to enhance it, but how can I do it dynamically? Because
yep. So let me repeat the question. I missed the second question. Maybe we can talk about that. But first and three are very common, so it will interest probably several persons. So the first question is, how can I programmatically upload the list of values or the list of sample iterants or change my intent model? But your question was specifically about the list of values for a slot. Currently, you cannot. So you have to copy-paste and go to the web console. Don't show it me. don't shoot me. We know that it's a very, very frequent developer requirement to have some kind of API or programmatic access to that, so we are working on that. Stay tuned. It's cooking. And the third question was, how can you know about the sample utterance? How do you know how your customers are interacting with your skill? And maybe you will start with a small list of sample utterance. How do you enrich that? We don't provide the direct sample utterance, or we don't provide the direct utterance to your skill, as you saw in the JSON. It's the intent, so it's the translation after natural language understanding. So currently you cannot. You don't know how your customer interact with your skill. If you have a partnership relation with us, if we are working together on your skill, we can give you some hints, because internally, of course, in our systems, we know exactly what the customer told to Alexa. So the big names we are working with, we work closely with them, and we provide that information. If you don't have a close relationship with us, sorry, as of today, you have to rely on customer feedback, on user survey. Very good experience is just to lock a couple of your employees or a customer in a room for 1 hour with your prototype, and you observe how they interact. You just give them minimal guidance, and you record that on video. This is super useful to learn how customer actually will talk to your skill. We do that with real customer. We lock them in a room, we feed pizza through the door, and we don't let them out after 1 hour or 2 hours. You cannot. So the question is, can you make relationships between slot types? As of today, you cannot. We are working at improving the slot model. I cannot give too much details. I cannot give you when it will be there, but we are working on making a much richer model for slots in the very near future. Yep.
Would it be possible to give Alexa some kind of memory so that she remembers the color over seconds?
So the question is it possible to give Alexa some memory? Yes, you can do that, but you have to program it by yourself. So many customers use DynamoDB, which is the NoSQL database as a managed service from AWS. It's something that you need to program at your skill level, but it's a very good practice. Anything that you can give Alexa that gives some feeling that you're actually speaking to a person, so that she recognizes you, she remembers what you said last time, she's happy to see you back if you didn't use the skill for a couple of days or weeks, do that, but you need to write code to persist that in a database.
And the second one, can Alexa recognize who's talking to her?
Can Alexa recognize who is talking to her? Not yet. Stay tuned.
You can only set thumbs up or down for a song playing on a custom radio station.
When I say Alexa, she's listening. So we are out of time. Happy to continue the conversation offline without the microphone, but we have to give up the room to the next talk. So thank you for your interest for Alexa and for machine learning.
Thank you so much, especially to the people that came also to the second session. We're really humbled by your patience.